Welcome to Series 5 of the Animated Maths for All video series. Prepare to learn, grow, and excel in mathematics. We are ready to start our learning journey today. Get ready to explore an exciting concept in mathematics. Today, we are going to have a great time on our field trip to a place where we will understand new concepts. Look at these people collecting water. Water is a precious resource and often needs to be measured and conserved. Water is precious. Do not waste it. Meet the community of Mathville. Everyone is busy collecting water. Have you ever wondered how we measure exactly how much water is inside these containers? That's a huge overhead tank. Wonder what its capacity is. The students are observing the waterworks to find the answer. We will learn in our classroom how to find the capacity of such huge tanks. Here is a close-up of water filling a bucket from a tank. Water level is reducing in the tank and increasing in the bucket. Finding the volume of a bucket or barrel is easier when we use the difference in the volume of water. This barrel looks huge, right? In math, we call the amount of space inside this barrel its volume. Volume tells us how much stuff a container can hold, whether it is a huge barrel or tiny cup. Dear students, I hope you enjoyed the field trip. Now settle down to explore and enjoy the concept of volume further. Look at the jar of water. The jar is an irregular solid, so it is complicated to calculate its volume using its dimensions. The water in the jar was emptied into 3 glasses. We know the volume of water in each glass. If each glass has 150 milliliters of water, how much water was there in the jar before? Think about the total volume. There are 3 glasses, each with 150 milliliters of water. The total volume is 3 times 150 milliliters, which equals 450 milliliters. So the jar had 450 milliliters of water. Now let us find the capacity of the barrel. We can calculate the capacity of the barrel by finding the difference in the volume of water in the tank before and after filling the barrel. Oh no, we let the water overflow. We won't get the correct capacity now. Let's refill the tank and try again, being more careful this time. The water is now just filled to the brim of the barrel. Turn off the tap now. Use this formula to calculate the difference in volume. Base area times the difference in the level of water equals the difference in the volume of water. H1 is the original height of water, which is greater, and H2 is the new height, which is lesser. Therefore, our formula uses H1 minus H2. Yes! H2 to be subtracted from H1. How do we get this formula? Let's break it down step by step to understand the logic behind calculating the difference in volume. Let us see how we arrive at this formula. Look at the explanation on the blackboard for clarity. Step 1. Define the 2 separate volumes. V1 equals base area times H1 and V2 equals base area times H2. Step 1. Define the 2 separate volumes. The volume of water at the start is V1 equals base area times H1. The volume of water at the end is V2 equals base area times H2. Step 2. Calculate the change, difference. To find the difference in volume, V_diff, we subtract the final volume from the initial volume. Difference in volume equals V1 minus V2. Base area times H1 minus base area times H2. Step 3. Factor out the common term. Since the base area is the same for both, we can factor it out. Base area times H1 minus H2. The base area of the tank is 500 cubic centimeters. The original height of water, H1, was the height of the tank, which is 70 centimeters, as it was filled to the brim. The new height, H2, is 40 centimeters. We can now apply our formula to find the difference in volume. Calculate the difference in volume. Base area times H1 minus H2. This is 500 times 70 minus 40. 500 square centimeters times 30 centimeters equals 15,000 cubic centimeters. Base area of the tank is given to be 500 cubic centimeters. Original height of water was height of the tank as it was filled to the brim, which is 70 centimeters. The difference in volume is 15,000 cubic centimeters, so the capacity of the barrel is 15 liters. 1,000 cubic centimeters is 1 liter, and 15,000 cubic centimeters is 15 liters. Now, let us explore a different scenario. Original tank and barrel has been replaced with a cuboidal tank A and cubical tank B. Using the formula, we can find the volume of cubical tank B. A cubical tank B is filled to the brim with water from tank A. Tank A now has 6 liters of water left, and the length of tank B is 20 centimeters. How much water was originally in tank A? We will use the same principles to determine its volume and capacity. Remember, water takes the shape of the container. 20 centimeters times 20 centimeters times 20 centimeters is 8,000 cubic centimeters. Excellent! How much is 8,000 cubic centimeters in liters? The volume of water left in tank A now is 6 liters. How much water was there in the tank originally? 8,000 cubic centimeters equals 8 liters. This is the volume of water used to fill tank B. So 6 plus 8 equals 14 liters is the original volume of water in the tank A. Yes, correct! Well done, students. You have now learned to find the volume of the cubical tank using difference in water level. Do you think we can find the length of this cubical tank by using the volume of the tank? We will see it in the next session. Thank you for watching Animated Maths for All series. We will soon meet in another interesting session.